Hey everyone, thanks for joining today's Common Lisp Study Group. A couple of announcements before we begin. We're going to take a brief hiatus next week and the 20 up to the 1st of October uh, due to some prior commitments I have. I do apologize for those frequent viewers watching this stream. We will touch base again October 1st, and then I'll announce on Meetup as well as in Discord and the Lisp Slack channel when the upcoming broadcast will be. It'll be a little bit what's the word, sporadic, primarily because I have a couple of school commitments I have to take care of. And I'm looking at my schedule so I can plan accordingly. Stay tuned for those announcements on all three channels of communication, and hopefully I'll get that squared away in the next couple of days. The other announcement that I was going to mention is and I'm just going to briefly bring this up, is the upcoming Lisp Game Jam that's coming in October too. If I remember, I actually had it open, and it looks like I removed it. Lisp Game Jam October. It was in. Yeah, there we go. So, for those of you who are going to join the Autumn Lisp Game Jam, it's going to start October 19th and it's going through the 29th. It's a week-long game jam to learn about writing games in Common Lisp. We have the organizer with us, Michael Fiano, here on the channel, and hopefully at the end of today's discussion, I'm going to have him just, touch base on the differences between this game jam and the spring one. Today we're going to be discussing Chapter 5 of Object-Oriented Programming in Common Lisp, specifically controlling. The title of the chapter is a little bit is about taking full control of the dispatch methods that are available to you inside Common Lisp. To get started on this, I'm going to begin by just briefly reviewing up to what we reviewed last week. Just primarily that I mentioned last week that Common Lisp, if you're just using vanilla Common Lisp, the bare basic features are available. You're going to end up doing classes and subclasses, and you're going to define generic methods, and you will, if you have subclasses that are going to be doing some stuff in addition to what your superclass is doing, you can add methods that are called before methods that could add some side effects that can be executed prior to the primary method, and you can have methods that do side effects after the primary method had been executed. To show this, what I did was I went ahead and cleaned up the example that we had last week, the bank accounts example. This is all checked in to Git. You can get it from the following address. I think I had it open, but it was.
Just a reminder to share your screen.
Excuse me?
You're not sharing your screen.
Ooh. Okay, I did that again. Sorry. Let me just do one thing. Okay. Yes. It's sharing on the live stream, but I keep forgetting I also have to share it inside Hangouts as well.
Good now. Thanks.
No problem. So for those of you who want to check out the code, it is available on GitHub. I checked it in about an hour ago. It's AtlantaFP/AFP CLOS tutorial. It has the bank account example, and I'm going to grow this into several other examples, time permitting, so that way as we go through it, you have a one-stop shop for all basic running examples of basic features that are available in CLOS for you. So you can go back and use this as a reference, hack it, grab some of the code examples, and extend it in your own programs. To get started is our bank account example is fairly simple. I'm just going to open up the base class here if you just give me a moment. We'll have different types of bank accounts, checking and savings account, but all banking accounts are going to have sort of the same three basic properties. They'll have a customer name, someone associated with their account. Usually it'll be a customer number, but I'm just making this a very simple example. You will have a balance associated with that account, as well as a type. The account type is based on the balance that are going to actually be passed in, and we update this ourselves internally based on whether certain balances are met, and we update it accordingly as we do that. Our API is very simple. Again, two basic operations. You're either going to withdraw money from the account, which means you're grabbing money from the account, or you're adding money into the account. Nothing very spectacular about this. As you can see at the top level, both our bank accounts, whether they're checking or savings, you can deposit the same way and withdraw the same way. So these are your basic primary methods that you might want to implement if you're writing such a program. Let's say that we're adding into our checking account. Well, in our checking account, which I'll just pull up here, checking account class, which is a subclass of bank account, we might have like a flag that checks to see if we overdraft, if we withdrew too much money from our checking account than what the balance is. We might have something that checks to see that the account has a certain minimum balance associated with it. So we, in this case, are guaranteeing that all classes should have a minimum balance. And that is something that we're going to leverage today when we start talking about our round methods. We have a simple constructor here that we went ahead and created that will take a customer and a balance and instantiate the checking account by making a call to make instance. This is something I added earlier today prior to our discussion, primarily because I was looking at a couple of things and I realized that I was implementing the same code, so I refactored some of this code out. So if you wanted to, like, say, after you constructed a checking account, you wanted to check the balance and see if it's of a particular size, and if the balance hits a particular dollar amount, you wanted to change the type of it on the fly. You might want to have this little helper function that goes ahead and says, okay, what's the current balance right now available at it, and then we can go and set the internal flag for the account type accordingly. And that's what I do.
That could be simplified a little bit. The greater than, or all the comparators there, those functions you're doing in the and there.
Yeah.
Those comparator functions are actually variadic, so you could
Oh,
just put,
right. That's
you could do one call instead of wrap it in and.
That's actually a good idea. I forgot that you did this once before. So
it'd be a little bit more readable, I think.
Let's see here. That's actually. Yeah. Okay. All right, that makes sense.
Yeah, that looks a lot better.
All right. Okay, I'll check this in later on. Let me see something here. Illegal function call. Did I mess something up here? I might have. Yeah, I did. Stupid me. This is why I'm using Vim my Vim keystrokes, but I keep forgetting. I didn't have evil smart parens turned on in this buffer, so I have to.
Oh, just push. Wait, what are you missing? A paren there? Closing paren?
Yeah, I already turned it on. Let me just turn on evil clever parens mode, so it's a little bit. Yeah, we're good. All right, quit. All right.
So you're gonna have to.
You were gonna say something?
Oh, does it compile now?
Yeah, it compiles.
What's that warning?
Undefined function account balance. Did I mess up something? 1 second. Oh, I see what I did. Okay. It's because I didn't load it. I didn't quick load my project into this. That's that's something that should. Sorry. Let me go ahead and do that. Right.
And if it wasn't written to disk, it's going to load that old code that you had.
Right. No, I already saved it, so we should be good. But just as a double check, yeah, we should be fine. All right.
Cool.
Then, of course, I call this inside initialize instance. We've talked about initialize instance and construction in the last episode. For those of you who are just joining in today, you should check out the last episode, the first part of this series that talks about object construction, that goes through the different types of object construction. Also, as we discussed last week, and just to finish this off, you have these ability to do side effects after a primary method has actually gone through and updated, does whatever it needs to do and return some sort of value. In this case, our different types of accounts might have different types of account updates. Like savings account has only basic and premium, but checking accounts in this example has 3 different types of flags: basic, premium, and platinum. So I added 2 different functions inside of it. We could probably simplify that. I didn't think too much through this when I created this example. So if there are any suggestions to update it or to make the example more clear, feel free to make suggestions.
I think there's a logic problem in what we just changed there, because there is there's no case for when the amount is equal to 10,000.
Oh, yes. That's what I need.
So you actually have to change the middle one to be less than or equal, I think.
If I do less than or equal, then this guy has to be strictly less.
Yeah.
All right. Got it. With half-open intervals, that's what I was essentially trying to do, where it was, so in set notation, what I was trying to do is minus infinity and 1,000, although really it's like 0 and 1,000. Sorry, 0 and 1,000, and then 1,000 and 10,000, where the 10,000 is included in the upper bound in that second class. But I didn't think that this is fine. We can work through that too as well. That's okay.
Another thing that might not be so obvious, when you're accessing generic functions, which slot accessors are, that is runtime dispatch. So I mean, if the first 2 branches fail, you're still doing the runtime dispatch every time for account balance. Usually, what you could do is wrap bind a let binding for balance equal to account balance, so that way it's not a generic function dispatch every single branch that fails.
So what about using with accessor, something like balance, account balance, account?
Well, that's just usually creating a simple macrolet.
But it doesn't actually bind it. Is what you're saying? Sure.
It's not specified.
Got it. Okay. I see what you're saying. Let me go ahead and first do this.
I mean, it's just, it's you don't have to do it. It's just something that some people overlook sometimes, because accessors are so easy to use that they forget that they're generic functions and they do have a runtime cost. So if you're doing lots of branches, and this is supposed to be highly performant code right here, this is going to be a big slowdown, especially in like a tight loop or something.
Okay, fixed. Not a big deal. I mean, that's a good point, and and since we're doing only a read here, not really a modification each time, really, what you're seeing is absolutely a good idea. So that's fine. I went ahead and changed it. This should compile. It compiles. Okay, good. All right. I did the same thing here just to show you guys. Like I said, sorry, keep forgetting that I'm in Lisp mode. All right. To our savings account example here. Savings. And again, like I said, it's the same code. I'll fix this code up using creating an after method for each of these sort of checks to see if when we do a deposit or a withdrawal, what does our account type change to. I did that particularly just because I was thinking about computed properties inside Common Lisp from a data model perspective. So this is just me illustrating after methods, but also at the same time sort of showing that you could create sort of like a reactive style program inside Common Lisp simply by leveraging what is already available to you. You don't have to do too much too much boilerplate to actually implement that kind of stuff yourself. So before, after, and primary methods being what we're seeing here in our example, constitute what Sonya Keene calls, and what I've seen in other places, the standard framework for doing method dispatch inside Common Lisp. If you're doing nothing else and you're using CLOS, and you're trying to create really modular code, you will almost always do some sort of combination of using before, after, and primary methods if you're just sticking to the core framework available to you. But sometimes that may not be what you want, right? Sometimes that you may want to have a bit more control as to when your core framework gets called, when your primary method gets called, and so forth. And what CLOS gives you is this ability to say, okay, well, we can allow you to control when your core framework gets called by allowing you to tell us when you want to call it. Specifically, there's a function called callNextMethod, and this is going to be the basis of two different approaches to actually dealing with method dispatch inside Common Lisp has an extension to the core framework, specifically around methods. And there's a technique that I honestly haven't seen in code bases. Maybe some of the more senior folks that are here might be able to provide us with some information, and that is calling shadowed primary methods. And I don't know when you would actually do that. So let me talk about around methods, and I hope we can talk a little bit about the second case a little bit more. So what are around methods? Around methods is basically nothing more than a wrapper. It's a wrapper that allows you to do some sort of setup, probably do some sort of computations, and then just tell Common Lisp, okay, I'm done. Go ahead and call the core framework to do whatever it needs to do. It basically bypasses the method dispatch that the standard method combination provides you, and allows you to imperatively dictate when that method gets called. So to give an example here, let's say that we want to check to see if our balance is a certain size, and if it's not, inside our checking account, and if it's less than a certain amount, particularly a minimum balance, we will go ahead and set our overdraft flag to true. This might be the case in some situations where certain accounts expect the minimum balance to be available. Otherwise, the bank can notify you saying that, hey, you're less than this minimum balance. What are you going to do? What do you want to do? The way you could write it is to just go ahead and write a before method to test this every time. Or what I would do is I would write a round method in this case, just because it's a specific case that you'd wanna deal with, and you want to deal with it ahead of time, before you go and call the injected framework to do whatever additional stuff that it may happen. So the way we write the around method is instead of after and before, as you've seen in our previous examples in writing the core framework, we just use :around to actually go and create an around method. Of course, the function signature is going to match what is already given in the generic function interface. It should match exactly. The only difference is the method combination type that you specify. And then you can go ahead and do what you want to do, which is, in this case, we're checking. I'm going to go ahead and do with slots here because I'm not going to try and think about how to do this. Checking count. And we'll go and check to see if our account balance is less than the minimum balance. If it isn't, if it is, we're going to go ahead and actually do this too. Overdraft P. Just make sure that, oops, sorry, what the heck did I just, just wanted to make sure my flag is correct. Okay. We'll go ahead and do set F overdraft P to be true. Okay. Really, this should be when. All right. And let's see, just one more thing that I want to check. That's not what we're doing. We want the difference between, oops. Oops. We're checking to see if if we're about to go overdraft, and then if it is, it's going to set it. Of course, we should technically extend this to say if we are already in overdraft, we should throw an error. I will go ahead and add that. Unless no, actually, it should be an unless, and then I can write an after. No, it should be an if. Overdraft P. We'll throw an error saying you already withdrew. Actually, this is not deposits, this is withdrawals. I'm a dummy. What I need to do is, let me do this as a withdrawal. I apologize, folks. This is actually a withdrawal. You already withdrew beyond your minimum balance. Okay. Oops. There we go. That's it. All right. So, as you can see, what we're doing is we're checking to see if we already withdrew too much. If we did, then we're going to just tell you you already withdrew beyond your minimum balance. Otherwise, it will go ahead and set the flag when we do it. To see this happen in action, I'm going to go ahead and first converter, go into my package, create an account, checking account, create, let's say that I have $1,000. All right. So now I am technically in the premium level account. Let's go ahead and withdraw from this guy. And for folks who have used REPL, star means the previous result that we just got. Let's say that I'm going to withdraw $5,000. Okay, it's going to allow me. There is a bug in that code. What is that problem? Oh, I'm a dummy. Sorry. I can't use this here. That's a class method. I can use checking account minimum balance. Call this guy. I forgot I made that into a class in that class variable. Okay. Let's do this again. We create a new account, withdraw 5,000, sets it to true. Now, if we try to withdraw again from the same class here, class instance, let's say 500, it should throw our error saying that you already withdrew your minimum balance, beyond your minimum balance. So, as you can see, what's happening here is we're always executing this code, and the second thing is and this is more important, actually that's interesting. I didn't do call next method on this guy and already tried to do that. I just
no, you didn't, and that means that all those methods that would have been shadowed will not be called. That's
right.
That's where the method chain stops right there.
Right. That's interesting.
Well, it will call the before and after methods of the most applicable method you're on right now, the checking account specialization. But it won't, it won't go farther than that.
That's right. So in this, what happened is I set the flag without actually doing the withdrawal. So give me a second here. I have to fix this. Call next method. This is what has to happen. We allow it to withdraw once, and then the next time it'll check it again. So let's make sure that that's correct. Okay. Account balance.
Actually,
that should work, actually.
That call next method is only going to occur when the conditional is true.
Ooh, that's right. That is
when
right.
Both conditionals are well, one is false and the other is true. So you want to put that call next method probably on the outside of if form.
Yeah, the outside of the if form is what I have to do right here. Please. Okay. Come on. Okay. So if I do withdraw and called arguments, what is it?
What's it say above that?
Let me try this one more time. Okay, this is right. Okay, good. Now if I try to do it again, except using star
it really is, and Elijah has a point. That is nothing more than a before method.
It is nothing more than a before method. I should really write that as a before method, come to think of it. But I was going to add some additional things in there.
The only thing different about it is it's going to call the before method. It's going to call that, and then it's going to call the before method after that.
Right.
Then it's going to call the primary method, then it's going to call the after method. I mean, if you wanted to split the code up into separate functions, I guess it's okay, but it's nothing more than a before method.
This piece is nothing more than right here, I guess, is, hold on. This piece here could be written as a before method, right? I don't need to use call next method in this guy. at all then if I make this into a before method, right? So if I did this,
Right. Right.
did this.
Yeah, that is basically the same functionality.
Right. But
except that you still have that around method in your image, so not both of them are going to fire off.
Right. Which will cause an error in that case because the flag will be set, and then it'll say, "Oh, wait a second." Okay.
Yep.
So I'm going to keep this guy as an around method for the time being for illustrative purposes. Like I said, there are cases where what you want, it should be a before method or an after method. But this is a contrived example that I'm coming up with that sort of shows off what it can do. I will obviously there are other better uses for around methods. Another one would be like benchmarking, but I didn't have a clear example of benchmarking that I can actually illustrate that particular piece where you can start a timer, exit a timer, and do some sort of heavy computations.
But around methods are useful for like hooking into other libraries. Like say a library had a method, and it already had a before and after method defined for it, but you wanted to do something before the before method.
Right.
You could define your own round method using the symbol for the method in that package.
Right, and there's another thing that the chapter mentions, and I think Elijah, you mentioned too as well. I think in one of our previous discussions, primarily that around methods can allow you to essentially set up your dynamic variables, your global variables before invoking a particular, I guess, core framework call. If you're using like any sort of like global variables, like in the binary parser example, right? If you could have you had a lot of global variables in there that you created a dynamic extent to a macro, you could have also used an around method if you had a top level parse function that you could pass into where each of the individual method calls essentially just.
You sort of already illustrated another use for around methods. Like, say you had a few different subclasses. Say you had like a checking account and an account class, but you didn't want the next applicable method to fire off. Then you would just exclude the call next method, and you could do that at any point down the chain of the applicable methods. So say like you wanted to stop after a certain amount of subclasses, you could just define around methods for all of those, and at whatever point not include the call next method, and it would stop right there.
Yeah, that's actually a very good point.
Methods.
That's you can the main takeaway though is around method gives you full control of where the core framework can stop. It bypasses and gives you full control of how to deal with before, after, in primary method execution. That being said, there are severe limitations with around methods, at least from what I was reading, not only in Sonya's book, but on other sites, primarily that in some cases it could lead to extremely non-modular code, where you're tightly bound by how the applicable around methods around your vicinity, how they're being executed in your image. Use wisely. It does give you some very nice control features. Like I said, the main uses I've used it for is primarily because I don't want to touch the core implementation of some library, but I wanted to see bottlenecks, so I add instrumentation using the around method to see where potential bottlenecks are, so I can go and clean up code. That's how I've used it. I know other people may have used it in other ways. So around methods let a lot less class control. What? I don't understand what you're saying, Elijah. Could you elaborate a little bit? wait, never mind. I understand. I misread that. Yes, that's right. Right. So Elijah makes a good point, folks, and that is specifically that around methods let parent classes, which are less specific, control what child classes can do. It gives you more control over the call chain as to where something can be stopped and where something can must happen. Of course, like I said, as you can see in my previous implementation of what we were discussing earlier, sometimes your around methods of what you're trying to accomplish could have simply been accomplished by you writing a before or after method for that particular class. But call next method, this call next method function is not only useful though for around methods, and that brings us to our second discussion that honestly I wanted to open up the table for folks who have more experience in this than me. So each class, whether it's in a class hierarchy, could have its own primary method. Like checking account could have, instead of implementing, the after method for deposit and leaving its implementation details to a bank account, it could have created another primary method. That means, and what I mean by primary method means it has no method qualifier here, method combination qualifier, when it's trying to override or implement a particular generic function. And the checking account could have done, some additional features and return certain values that could be then passed on to other classes that are subclasses of it that also have primary methods.
There's a very important rule to follow if you're passing arguments to call next method, though.
Right.
That is that you cannot alter the applicable method list of the original generic function as it was called, which means you can't pass in another class so it skips an applicable method, because what will happen is undefined behavior. It's the standard specifies that it should raise an error if that happens, and the terminology of the spec as far as should be signaled means that it might and it might not. It's up to the implementation. It will fail completely on closure, Common Lisp. SBCL will let it slide. It'll do what you expect, but it's undefined behavior, so you shouldn't expect that. Do not change the applicable method list if you're passing in arguments to the next method.
So I don't understand what you mean by changing the applicable method list, because I thought that is computed once you've when you're starting to add.
Well, when you call next method, you're giving the arguments to the next applicable method.
Right.
And when you do so, like say it's going to call the next method that's going to be called is what are you doing? Savings checking account. The next method is savings account. Well, say you have some special account and you wanted to pass that as the next argument, so it skips over savings account. Gotcha. Or whatever. Mm-hmm. That's illegal. That's undefined behavior.
Okay.
You have to let it call what it was going to call.
Right.
As far as the applicable methods.
So you're saying that the ordering is it should be guaranteed, and there's no way for you to control.
Yes, you cannot change the order with call next method.
Gotcha. Okay, that makes sense. All right, that actually is a good thing in my opinion, because it makes it a bit more predictable then for you to know if you're doing primary methods what the call chain would be. Right, it'll be always most specific first, if I remember correctly, for doing call next method. Hold on, I gotta go look at my notes. Yeah. A lot of these is going to be most specific, folks, first, for at least for before methods, after methods. Before methods, primary methods, and in the case of around methods. After methods is actually least specific first, and that's because it's it's an envelope, right? You're pushing things onto the stack, and it's going to be last in, first out. It's going to.
So is checking account a subclass of a regular account?
Yes, checking account is a subclass of our bank account.
Okay, so an example would be in your call next method. Go to the bottom.
Yep.
If you were to say, what's the signature for that? Go to the end of call next method.
So I don't think
it's just a list of slots.
No, that's just with
a list of arguments for the method, right?
It didn't actually show. That's what I was trying to get. Give me a second here. I was gonna use what's it? Sorry, describe. Where is describe function? Help. Where is describe function? Oh, Jesus.
No, that's not going to show anything.
Yeah. No.
But anyway, close that.
I'm trying to close it.
You got to do
space
BD.
Yeah, that's right. That's a bug in I was going to.
So you're specialized on checking account right now, which means your call next method is going to do the the next method in the chain, which is a regular account class.
Yes. So
if you were to change that so that call next method called savings account, that would be completely wrong because that's changing the ordered set of applicable methods.
Right. Okay, I see what you're saying. And you're saying that you can actually do that, right?
It would work. It would work on SBCL.
Hmm.
It's not guaranteed to work everywhere. In fact, it'll straight out error on CCL.
I am actually going to try this in a different thing and then submit an example where this is bad and it's undefined behavior. But I'm because I'm just a bit curious about this. But really, the bottom line is you should never do that, right? You should actually.
Right. You should know the order, the applicable methods for your method chain and never alter that. Let it do what it was going to do. You could change the arguments as long as you're not changing the applicable methods that are going to be called. If that makes sense.
That makes sense. I have to come up with a better example where you would want to do that.
Sorry, I can't really think of a good example right now. But
no. I get what you're saying though. Like if you have siblings, it's almost like if you have subclasses of each other and each of them have their own implementation. You can't go to a disjoint subclass that just has an override, just happen to have an override to this generic function that has its own implementation because that's undefined. But in the case of,
say you had a withdrawal method on just a regular account.
Yeah.
Okay. And now call next method for checking account is going to call that method. And you have an around method for a regular account withdraw. Say that you pass in for that regular account method and the around method that you call next method and tell it checking account, so that there's a infinite loop.
Right.
That might actually work on SBCL. I'm not sure if it would be smart enough to catch that because SBCL is very lenient when it comes to changing the applicable method list, but it will fail. In fact, if you change the order at all, it will fail on CCL.
Got it.
And that's why you don't want to introduce the loops or anything like that, or change how the methods are computed.
Right.
They should remain static.
This is actually a good segue into the next thing that I was going to discuss. But honestly, I'm going to say this up front, folks.
Elijah, yes, it does let you change the order, and it does not error at all, which is undefined behavior. It's perfectly allowed to do so. Some implementations do not, like CCL, I was saying. That will error. The specification, the standard says that when providing arguments to call next method, this rule must be satisfied or an error of type error should be signaled. Whenever the spec says should be signaled, it doesn't mean that it will be signaled. There's actually a terminology section that tells you all about when errors should be signaled or are signaled or must be signaled. It's all about the wording in the spec. Should be signaled means that it might or it might not. It's up to the implementation.
That just that just sounds like all sorts of crazy. Like, if you want to do that, why would you? I mean, that's just you're just opening yourself up to potential edge cases, and the fact that well, not even that. You're potentially opening yourself up to just very difficult debugging experiences that on Clojure, I guess, since it implements the spec more closely than SBCL, that's good. You just try different Lisp and debug your code that way. But in the case of SBCL, I'm surprised they're that lenient. So I was gonna look up one thing, which was
I want to find the section of the spec that says this. Oh, here it is. Okay, whenever the spec says an error should be signaled, this means that an error is signaled in safe code, and an error might be signaled in unsafe code.
And how do they define safe and unsafe?
Safe is when the safety optimization is at its highest,
Okay, gotcha.
set to 3.
Set to 3.
Which is not the default, I don't believe. I mean, it's up to implementations to define what they are as a default. And that could be the difference there between SBCL and CCL.
Interesting.
The safety.
Okay. So, all right. Let's continue on. Now,
if you type declare optimize in the REPL, it'll show you the current settings in the LDoc. Oh, thanks, Elijah.
Declare. Wait, I gotta read what Elijah said.
Declare. Open parent optimize, and then it should tell you the.
Here we go. Open parent optimize. Okay. And declare open parent optimize with no flags, right? I'm assuming.
Space.
Ah. Okay.
And okay, so yeah, you're not running safe code right now. Safe code is defined when safety is 3.
When safety is 3. All right.
And that is why CCL must have safety defined at 3 as a default.
That probably is true. I mean, I've seen I haven't seen it like complain too much, but I have seen Clojure on occasion when I write in unsafe codes that it almost spews out stuff that I thought SBCL will catch, but it doesn't. So this makes a little bit more sense as to some of my experiences.
So there's 3 different things according to the spec on when it actually the terminology the spec uses. There is an error is signaled. That means it's signaled in both safe and unsafe code. An error should be signaled. That means only in safe code is it signaled. And it might be signaled in unsafe code. And then should be prepared to signal. And that I'm not familiar with, but it's similar to should be signaled, except it does not apply that extra effort has to be taken on the part of an operator to discover an erroneous situation if the normal. Okay, so
okay,
yeah, but you gotta pay attention to the wording on as far as undefined behavior goes, and when an implementation is supposed to signal an error. For column-X method, it only signals an error in safe code if you change the applicable method list.
You change it.
So if you set safety to 1 or 2 or 0 or whatever, anything but 3,
yeah,
in CCL, it should work.
So
I'm wondering if we could actually show how that happens.
We could do that
in SBCL. I mean, right now, if we try calling next method with
So if I first do safety 3.
Yep.
There's no declare. Oh.
Oh, right. You got to declaim it at the top level.
Yeah. Okay.
Okay. So now you should never do this. By the way, this is going to affect your whole image. Every bit of code that runs in your whole image is now affected. So this is very bad practice, but I guess it'll illustrate the point.
Okay. Yeah, I agree. But I think it's important for folks to see what these problems are, so that if they see it, it will be.
So if we call next well, we don't have the setup for this yet, do we? Do you have any other withdraw methods for like savings account or?
No, but I can write one. Hold on 1 second. Because the way I wrote this is I allowed the account. I actually modularized it, which.
Well, we don't need an around method. Yeah, you could just regular primary method for another account type.
Savings account amount, and let's just, for the sake of example,
just print like foo.
Print foo. This shouldn't be called. Okay. All right.
Okay, compile that.
All right, got it compiled.
And now over in your other window there, where it says call next method.
Call next method savings account. Like this?
Well, no, you're going to have to make an instance of a savings account.
Oh, gotcha. Okay.
Make instance savings account.
I'm going to have to pass in information, so I'm just going to go ahead.
It doesn't matter, really. Just some random value.
Oh, yeah, I could do that, but 1 second. Customer name, blah. And balance 0. All right.
And
compile it. Okay.
No, we need the other argument, the amount argument too.
Amount. Okay.
Yeah, I agree, Elijah. But I mean, this should work. No, you have to put that after the make instance form.
Oh.
It's a second argument to your withdraw.
All right. Okay, that's right. Thank you. I'm dumb. All right. Thank you.
Okay. Now compile that. Now run your withdraw as you did before.
Okay. Give me a second. I'm gonna have to create a new one. All right.
Yep.
And withdraw.
Yep.
All right.
Do you see what happened?
Yes. Simple error. Call that one. Yeah. It's complaining.
Now try changing the declaim optimize settings to 2 instead of 3 for safety.
Got it.
And run the same thing again.
Okay. And hold on. Yeah, it worked. That's not cool.
Yeah, isn't that's pretty strange, huh?
Yeah.
CCL is safety 3 by default, and you will run into that error before anything unexpected happens.
That's actually very, very dangerous.
Yeah, so basically don't ever change the applicable methods when you're passing arguments to call next method.
Just
you don't know how it's going to behave on other implementations.
Simple rule. If you're using call next method with no arguments. If you're going to use call next method inside, and allow your Lisp implementation to dictate the applicable method list, because it would have computed it beforehand for you. So I think that's really what you're saying, right? Don't pass anything to call next method, because it's going to change the method call chain, and could lead to undefined behavior unless you turn on your safety settings to really high. You will never even notice it. Or if you use closure.
The applicable methods are pre-computed, Elijah, but it's a type error if the ordered set is different than the ones that were already computed when you pass arguments to call next method. That's the exceptional situation on the call next method page of the spec if you want to read it.
Actually, hold on, I'm going to try something here. 1 second, I need to close one of these buffers out so I can actually look at stuff. Okay, and that one just showed the error that we did before. I wanted to see.
Anyway, that was kind of a derailment. I'm sorry, but you shouldn't change the arguments like that. It's
wow.
I ran into it a few times until I really dove into the spec and found that little bit about safety and whatnot. It's confusing.
All right. So okay. So the next topic that we're going to be talking about, and I really doubt that we're going to actually get through it completely today, I'll be honest with you, but I'm going to try my best, is method combinations.
Oh boy.
We're not going to touch building our own method combinations in this discussion. We're only going to be talking about what is available in Common Lisp for you to do stuff beyond what's considered the standard method combination. But in order for me to do that, in order for me to explain that for the noobs that are watching this, I have to take a step back and explain, what we were talking about earlier about, effective method, this notion of what an effective method is. CLOS, what it does is it takes your before methods, your primary methods, and your after method, and what it does is it compiles what it considers to be the effective method that needs to be invoked. And what this effective method is nothing more than in the primary, the standard method combination case, it's nothing more than, and this is just going to be a comment that I'll put in the tutorial. It's, according to book at least, one implementation would be multiple value prog n 1, and it will go through and actually I'll do it this way. I'll put it in the buffer here. Come on, there we go. There'll be a multiple value prog 1. And it will go through and implement a prog n where it starts with the most specific method before methods, okay? And it's going to loop through all this. There might be one before method, there might be n of these, but it will keep going with the most specific before method with your arguments. And then it'll keep going until it hits the least specific before method. So if you have anything in between, so let's say that we have two classes where one is a subclass of the other, and you had an override of a method, like in our withdraw case, what happens is if I had a before method on my checking account or savings account, that will be called first before the bank account's method will be called. So after all this is done, what you would then end up calling is the most specific primary method with the arguments. And finally, you can do your cleanup, which ends up being your least specific method before after method called first, and then your most specific being called last. This is what I was talking about earlier when I said that it was implemented in an envelope type fashion. This is done by the CLOS compiler. I mean by the Lisp implementation itself and the CLOS implementation. It recognizes this standard method combination, its built-in method combination, and if you use these type specifiers, these method combination specifiers indicating what are your before methods, what are your after methods, and for primary methods, of course, as I mentioned earlier, you don't have to specify a method combination qualifier. CLOS will take those hints and it will look at the type hierarchy and it will generate this effective method for you. Now, in some cases, you may want to use different method combinations beyond this that's available, and you want to specify the roles that how a method should be invoked. Well, that's what CLOS is calling your method combination, and there are plenty of available method combinations beyond just this standard method combination. And they all work the same way, at least the built-in ones. And that is depending upon how you, depending upon which method combination you use, that is, it will end up being, it'll end up essentially generating something along the lines of a form where you specify an operator, and then it'll go through and list out, your primary methods. Now, this brings up one thing that I'm going to at least mention, and hopefully, Michael, you can, provide some insight on this. From what I read, and I haven't read the Common Lisp hyperspec on this yet. These method combinations seem to only work on primary methods. I don't see anything where they say it's going to use before or after methods. Is that the case? So like if you use prog_n or plus, for example, which I think you said that you're familiar with prog_n or plus, is it assuming that if you're going to use the plus method combination, each method in your type hierarchy is going to be a primary method?
That is something I couldn't answer. I would have to test. I've never tried, and I've never looked it up. So,
okay.
I could do so real quick while you continue.
Okay. So that, from my understanding of the text and my understanding of how method combinations work, that should be the case. It only works on primary methods, and what that means is if you're going to use any other method combination that's built in, and what I'm talking about is what the book calls and what the hyperspec seems to call the operator built-in method combination types. And there's about 9 of them available for you already. I'll just list them here. You got prog_n, plus, and your logic and/or. You have an append method combination, a list method combination. And again, these method combinations essentially generate this form of logic. That is, it says, okay, like for example, the prog_n method combination, you just replace operator with prog_n, that's the prog_n method combination. When you define a function that does that, you essentially have to define it the following way. You take your def generic, let's call it, some function, okay? And let's say that you're specifying it on savings account here in this case, although really it should be on bank account. Let's go ahead and say bank account, okay? And let's, you want to use something that is not the standard method combination. Okay, let's say that you're using prog_n, for example. When you're defining your generic method, you have to actually specify it this way, and that is, you define the generic function, and then you tell it, by the way, I'm not using the standard method combination, I'm using the prog_n method combination. All right, this generates, a function that uses the prog_n method combination. All right. Then, when you specify a method implementation of this generic function, what you do is you have to, in your primary method, that is, you have to specify your method combination qualifier. And in this case, you're telling it that it is a prog_n. All right, while in the standard method combination, it's optional it's not even optional. It's not necessary to specify a method combination type for primary methods. For all other built-in method combinations, you have to specify the method combination type. And this is what is used by CLOS to actually go look up the generic function and generate the this final implementation here. So let's quickly, just come up with an example here. Let's just use prog_n. Let's say that we're generating prog_n and we want to do some operation on bank accounts. And let's say that this is going to be a prog_n on our normal bank account and on our savings account. All right. Forgive me for a minute. I'm just going to go ahead and move this guy into our bank accounts implementation. And let's say that we have a default, primary method here for some function that is a prog_n. And by the way, I'll just show this to you. If you don't specify the method combination qualifier, this is what's going to happen. Account base class implemented. Let's make sure our generic function is compiled into our image. Okay, it is. If we compile this guy, you'll see that you get an error. It gives you actually a warning. That's surprising. That should have been an error. I thought it would be an error. It gives you a warning saying that invalid qualifiers for prog_n method combination in method. So it is attempting to do something that the Common Lisp implementation recognized as saying, hey, wait a second. I looked this generic function up. It's using a different method combination than what is actually being provided to me. So pay attention to those warnings, at least on SBCL. It should have been an error. I'm surprised that it's not an error. Michael, is it because I changed my safety that it may not be throwing up an error? Is it by default that the method combination?
I'm not sure. I mean, it very well could.
I will. Let me try this for the sake of discussion. Let me just delete this. I'm just going to restart my Lisp image. All right. So give me a second here. Restart Lisp.
I get a warning too, so no.
Interesting. Okay, that's something I learned. That's something new. I didn't think it would. I totally thought it would actually give you an error saying, by the way, oh wait, why did I restart again? No, that's not what I wanted to do. I wanted to do clear. 1 second. Okay. Clear. Thank you. Alright. Quick load. AFP. CLOS tutorial. What is complaining about? Line 23. What? Must have done something wrong. Hold on a second. What are they complaining
about? Close the debugger.
I think I know what it is.
There,
I think it's complaining about this guy, the call next method guy. Oh, hold on. Oops. Okay. Let me reload this guy. Oh, wrong line.
So
there's another error that's showing up in here. Yeah, that's what I thought. Let me turn off evil parens because for some reason I can't delete this guy when I use X. in evil clever prince mode. There we go. Now it should work. There we go. I was wondering what was that. I mean, that didn't look right. All right. So now that we have that there, and let me just take this guy out. You said that if I recompile this guy, yep, it's still in the warning. So that's that really is a warning, folks. So pay attention to your warnings if you're going to use other method combinations that are not the standard method combination. Once you do this, let's do some func account, savings account, and again, print savings account class function called what is it? Sorry. Okay. So we create an instance of open. Oh, I should first get into the implementation here. Comma SS. Thank you. Open savings account. Dang it. Savings account. And then I have freedom. Okay. Now when we call some func on this guy, what is it saying? Hold on, I can't read the entire message. The method combination type prog_n was defined with the short form, and so requires all methods have either the single qualifier prog_n or the single qualifier around.
Can I see your source buffer?
Yeah, sure. Let me just do that.
Okay, so some func. Is that the only function you have, or method? Some func?
Yeah, some func is the method combination here.
Okay, so with method combination, there's a second argument to method combination.
Oh, right, I see. You're talking about the identity with one argument.
No, it doesn't need to be a keyword. In fact, it can't be a keyword. I was responding to Elijah.
Oh, okay. What's the second one?
You either want most specific first or most specific last. Usually with prog_n, you want most specific last.
Okay. Oh, wait. You're saying that when I call it like this?
That is a keyword. Keyword symbol, most specific last.
Oh, got it.
Right after prog_n, in the same form.
In the same form. Okay. That's what I was asking. Yep. Most specific first, I think, is what I want. Okay. Oh, wait. Yeah, I forgot to compile it. All right. Do I need to recompile this guy? I'll do that anyway. All right. And let's see. There is something.
Okay, go to the
There is something I'm missing here, and I think
there's a method in that. There's a method attached to that function that shouldn't be there. I'm not sure if it was from before or what.
Okay. One more time, I'm going to go ahead and restart my Lisp and then reload everything. I don't have a progen version for checking out because it's not necessary to implement it. So quick load CLOS tutorial. Okay. Savings account. Some funk on a savings account. Okay. That was it. I had to restart my Lisp image. It must have been a recompilation error. So you can see here that what I did is by specifying most specific first, it's going to start off by calling the savings account overridden version of some function, and then it's going to finally call the base class version.
Now, usually with progen, you would want to reverse the order. Not always, but usually, because like say that every method was for side effects, and they were like set effing some slot or something. You want the most specific one to override what was set, what was modified.
Right. That's a very good point.
Reverse the order.
So
with most specific last in your generic function there.
I went ahead and changed that. Hopefully, okay, good. Okay, that worked as well. Must have gotten confused. So I'm a bit surprised that that changing messed something up, but okay. But yeah, so let's go through that piece of code one more time, just because I didn't add it before. Again, when you're declaring your method, your functions that are going to use different, other than the standard method combination, you're declaring your generic functions, and you want them to use something other than the standard method combination. You specify, again, your method combination that you want to use. In this case, we're using a built-in method combination called progen. And you're telling CLOS how the method dispatch should be invoked. Specifically, it looks at the class hierarchy and all of the overridden methods. All the implementations for this specific generic function. And based on this flag here, it compiles a form, effectively, that's going to execute in the order in which you specified here, based on this flag. So in this case, like Michael pointed out, the most specific class, or savings account in this case, is going to be called last in the progen implementation. So it literally, behind the scenes, took our implementations and generated this guy for us. Now you might say, okay, well, why not just write my own function that does this for me? I actually don't think you can with class hierarchies, because there's no concept of, like, say, casting in Lisp, at least as far as I know.
Well, there's coerce, but
so yeah, but I don't think there's a concept called that allows you to look up the hierarchy and then invoke a function. The Lisp implementation will do that for you. And honestly, I would rather let Lisp do what it does, because it's, in most cases, it is correct. With the exception of around methods, and say if you're going to do something crazy like implement your own method combination, and that's going to be, honestly, a topic for a different day, because creating your own method combination, there are two forms that are to create your own method combination. The form that I'll just mention briefly what the keyword is, and then we will revisit this a little bit more as we start getting more and more into, like, say, meta objects and creating our own getting into more control over in Common Lisp. But the keyword to create your own method combination is called define method combination. I encourage you guys to go look up in the Common Lisp hyperspec on the details of this. The basic idea of the short form, and I'll just show you the short form of this, is that it will allow you to specify, let's say that we want, we're going to implement our own version of progn, okay? The short form allows us to specify a progn method combination by the title. Then you specify the operator that you're trying to override. In this case, it's progn. And what that is this operator is not actually overriding. It's actually hinting at the at CLOS. If you remember what I said earlier, it's operator primary method. It generates this form. This guy is just doing like the equivalent of a substitution. I wouldn't say that it's an exact substitution of this, what was passed into this keyword argument. It might do something additionally more snazzier. I don't know. It depends on the Common Lisp implementation. But this is it. In the most basic cases, this is how you would implement the short form for your built-in operator method combinations. If you want an operator method combination that isn't available, you could just simply do this, and it'll go ahead and generate it for you. There are some cases where you want the optimizer to go and not generate that code and just recognize that, hey, I'm only passing in one form, just compile it in the most optimal way as possible. That will only happen if you generate the method combination with the flag identity with one argument set to true. And what that tells basically Common Lisp is the phrase that was used in the book is, this is an identity when it is called with the one argument. I was like, well, yeah, that's what the flag says. It essentially is a compiler hint that tells it to optimize for cases when there's only one applicable method. So if there's only one implementation of said method, and you passed and you invoked an object that only uses that method, it will just go ahead and say, okay, this is just a function call to this single applicable method. I don't need to do any sort of optimization. In fact, in the case of progn, I don't even need to generate the form. But that again is dependent upon who implemented the define method combination keyword. It's not uniform across implementations, but I do want to at least mention that if you have this turned on, your implementation could do some optimizations to any generic function hierarchy that leverages this particular method combination. There is a long version of define method combination, but I'm only mentioning it just for completeness sake. But today we will not go through that, just because honestly I have to try it out myself. I've never actually seen a complete example that generated a full-blown method combination using the long form. But are there any questions from anyone on the stream? Let me look at our chat. Okay, it looks like no one's coming in. All right. Yep, that's looks like there's no more questions here in the stream forum chat room. Let me catch up on some comments that Elijah made. Also, make sure you haven't forgotten the method oh, okay. All right, cool. Do you have any more comments on this, Michael? Have you? I think you said that you never actually tried anything beyond the standard built-in ones. I will say though, when I was reading that,
I only really use progn once in a while. Apart from the standard method combination.
Gotcha.
It does come in handy, especially like when you're like trying to make like mixins or some other OOP thing like that, where you want every method to fire off.
Cool.
One thing Generic functions in general. There is, like, I ran into a bug before.
Okay.
I was trying to write, actually, I was writing my ping load library, which parses ping images, and it has a few generic functions, and we were trying to make it very performant. But I mean, the generic functions that it did have shouldn't have been slowing it down as much as it did, and I realized that it was only slow on the first time a ping image was loaded. Every other time it was fast. The reason why that is, I'm not sure if this is implementation specific or not, but a generic function is compiled the first time one of its methods is called.
Okay.
It's not compiled at compile time. I'm not sure if that's SPCL specific or not, though.
That's interesting.
It's something to keep in mind if you're trying to benchmark a generic function.
Hold on. So you're saying that if you just defined a generic function but there are no implementations, it won't compile it? Is that essentially what you're saying, or did I misunderstand what you said?
No, what I'm saying is like if you have a few def methods,
Okay.
and you call one right after you start your image and quick load the project,
Yeah.
it's going to be slower than the second time you call that same method.
Oh, gotcha. Okay. So you're saying that when you load up your image, it doesn't necessarily have compiled everything. When you load something into your image, it doesn't necessarily compile everything. It's only on the
Yeah,
first
I don't know. Maybe Elijah
function
can shed some light on this, but generic functions are slow the first time you call them.
Interesting. Okay.
I'm not sure if they are compiled, their methods are compiled that like the first time you access them, or what.
That might be the case, actually. If that's what if what you're saying is true, in that upon the first function invocation, it's really.
I couldn't
slow.
find anything in the spec. So what I'm saying is, yes. When I was developing my ping load library, it does make use of some generic functions in places, and we were trying to figure out why it was so slow. But it was only slow the first time a ping was read. The second time it was actually pretty fast. And what we discovered was that a generic function, the first time it is accessed after you start your image and quick load a project, it compiles and caches method combinations. Okay, so yeah, it doesn't do that until the first access of a method. I'm taking it. Yep. Okay. So yeah, that's something to keep in mind if you're trying to like benchmark a generic function. You should cache it, run it a few times so it's cached.
Got it. That's. But then, does that mean then? No, that shouldn't matter when you compile an image.
Just watch. It was only the second time that was fast, or the first time that was slow. Every other time was fast. So yeah, that does coincide with what I experienced.
You don't. It doesn't affect when you compile the actual image, though, right? With it, like when you do a load and compile, it doesn't affect that, does it? Like if you try to do like say what was I like what is it called save Lisp and die, and you did like a quick load and compiled everything. No, okay, it doesn't affect it. Okay, sweet. Okay, thanks. That's what I needed to know. Okay, cool. All right. Well done. That's all I have for today. Oh, it's purely a cache. Okay. So SBCL, in SBCL's case, just to complete the thought on this, if you load a library into an image and you're doing a save and you use some of those functions, SBCL will compile and cache the generic function on its first use and then reset it as needed.
That makes sense.
That makes sense.
Okay.
Okay, cool.
So yeah, a generic function is going to be, its applicable method list is going to be cached, but only on the first use of one of its methods. Every other method after that should have the cache available and be pretty fast as long as SBCL hasn't reset it. each time you call a generic function, it'll compute an effective method. Yep.
That's right. And then that effect, in the case of SBCL, that effective method will get compiled and then reused. So the first time it computes the effective method, and then the second time it will reuse the cached one. If it's
okay, yeah, that makes sense.
Right.
So yeah, generic functions do have a higher cost the first time they're used on SBCL at least. Something to keep in mind if you're wondering why it's so slow and you haven't tried it a second time, like I did.
All right, cool. Well, like I said earlier in this discussion, we are going to be taking a brief hiatus. We'll be back October 1st. Again, I do apologize for frequent visitors. There are some additional obligations I have to take care of the next couple of weeks. But when we get back, we'll get into some real interesting stuff with CLOS, primarily the class inheritance, and hopefully update instance for a redefined class. if I can get my example running. So, but until next time, see Michael's stream on Sunday, and if you have time, please do participate in the fall Lisp Game Jam. And hopefully, Michael, if you can provide any more details other than what's available on it.
Well, the fall Lisp Game Jam usually doesn't have that many participants. Usually the spring one is, 100 people or so, and the fall one maybe a handful. So we're trying something new this time. It's kind of, I guess, for more experienced game developers, because you must conform to the theme of the Game Jam, and the theme is scripted on the Game Jam web page to be revealed when the Game Jam starts. So nobody knows what the theme is going to be until it actually begins. So it's a little bit more difficult, but I don't suspect that to be a problem, considering there's only like a few of the regulars that participate in the fall jam.
All right. Well then.
So if you want to try it, go ahead. It's just a experimental game jam this time to see how it works out, I guess. It was a suggestion by one of our participants. So if you want to try it out, it's it's on Reddit, I believe. We posted it to Reddit on the Common Lisp, on the Lisp subreddit.
Yes. Follow the subreddit. The Common Lisp subreddit is also available to you, and you'll see some pretty cool stuff that's happening in the Lisp world. So until next time, thanks for joining us. I'll see you then.
Thank you.